This time we are going to show the standard matrix of the given two linear transformations here. So to do that, we need to understand the definition of their linear transformation. We have here first from R2 to R2, and the second one is from R3 to R3. We need to understand this because before we could determine the correct vectors to be used in order for us to get the standard matrix following this definition, we need to come up with the understanding of the standard matrix of our domain. Okay, in R2, the standard matrix of our domain is in this form: 1, 0, 0, and 1. But for R3, the standard matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. These are called standard matrix because whatever be the results of all matrices in R2 and R3 respectively are generated from these two respective standard matrices. Now we are going to use the columns here. So let's focus first on the first standard, linear transformation. So this here, let's take it, it's considered is our vector E sub 1. So we'll have 1 and 0. And the second column, let's consider it E sub 2, 0, and 1. The standard matrix of a linear transformation is when we are going to use these vectors in determining the result here. So say for example, for the first, we have the linear transformation using the first vector here. In short, we are going to use here linear transformation of 1 and 0 in vector form. In short, this is equal to 1 and 0 is equal to the substitution. This would be our x sub 1 and this would be our x sub 2. So you will have here 1 plus twice 0, then negative of 1 minus 0. Okay, that would mean linear transformation of 1, 0 is 1 plus 0, and you have here negative 1, which will give us a result of 1 and negative 1. With this, we could also write this in the form of a vector, as it will be part of our final result later. So the linear transformation of 1, 0 is equal to 1 and negative 1. Duplicating the same process for our second vector taken from the standard matrix of R2. This means this is the linear transformation of 0, 1. So we have here the linear transformation of 0, 1 is equal to x sub 1 will be 0, so you have 0 plus 2 times 1, then negative 0 minus 1. In this case, we will have here linear transformation of 0, 1 is equal to 0 plus 2 and negative 1 here. So linear transformation of 0 and 1 is equal to 2 and negative 1. In matrix form or in column form, we have 0 and 1. You have here 2 and negative 1. Once we're done with these expressions, we cannot combine them because our goal is to come up with the standard matrix of the linear transformation. We're going to come up with an augmented matrix combining the two results. So you have here the linear transformation of E sub 1, the linear transformation of E sub 2, and so on and so forth. But since we are in R2, we end up here. With this, the standard matrix for our first linear transformation is this one here, 1, negative 1, to be followed with this 2 and negative 1. This is the linear transformation of our first, this is a standard matrix of our first linear transformation. Now, let's proceed to the second, as this is on R3 to R3. Again, this would be our first vector, E sub 1. You'll take it 1, 0, 0. Our E sub 2 will become the next column, 0, 1, 0. And for our E sub 3, our third column, 0, 0, and then 1. Same thing, we are going to solve for the linear transformation of each vectors. So we will have here the linear transformation of 1, 0, and 0. So we have the linear transformation of 1, 0, 0, where x sub 1 is 1, x sub 2 is 0, and x sub 3 is 0. So you have your 1 minus 0, 0 minus 0, then 0 minus 1. In short, the linear transformation of 1, 0, 0 is equal to 1, 0, negative 1. Next is for the of course, you could rewrite this first in terms of this. 1, 0, 0 is equal to 1, 0, negative 1. Let's proceed to the linear transformation of our second column, which is the linear transformation of 0, 1, 0. Linear transformation of 0, 1, 0, where x sub 1 is 0, x sub 2 is 1, x sub 3 is 0. So you have 0 minus 1, 1 minus 0, 0 minus 0. Then you will have this form here. Linear transformation of 0, 1, 0 is negative 1, 1, and then 0. Or you could rewrite it in this form. You have equal to the column negative 1, 1, and then 0. Now for the third, okay, we have here the linear transformation of 0, 0, 1, where x sub 1 is 0, x sub 2 is 0, and x sub 3 is 1. So going back to the definition like this here, right? So we'll have 0 minus, that's minus. 0 minus 0, 0 minus 1, 1 minus 0. So we'll have here 0, negative 1, and then 1. Or in this form. With all of this, we can now combine them into one matrix, as this will become the combination or the augmented matrix combining all the linear transformations. So we have here, okay. So our standard matrix for this second linear transformation is 1, 0, 1 here. We have negative 1, 1, and 0, and 0, negative 1, and then 1. This is again the standard matrix for the second linear transformation. So again, it's very important that we always review what is our domain, because we will base our standard matrix to that the standard matrix of that given space. In our last video concerning the same concern, we will have a linear transformation from R2 to R3 and R3 to R2, so that we could also implement different processes here. Thank you very much for watching.